In this video, we're going to go through or continue section 2.1 by looking at a very specific example with a Venn diagram and sets. Now, I'm giving you the Venn diagram, and I would take a second, pause the video, and write this all down. And I'm just going to kind of explain what it all means. So, a survey was taken, and they asked people how they get to work. And the options were public transportation, bike, car. All right. So public transportation, bike, car. And then I just realized there was one piece of information missing. There was 15 sitting out here in the universe that indicated 15 people who did not use public transportation, bike, or car to get to work. Okay. Maybe they walked or teleported if they're magical. All right. So here's the idea. We're going to ask a bunch of questions regarding this. And I kind of zoomed in a little so you could see all of the numbers. Okay. So in the center here is 12. That is a 12. And down here is 35. I kind of ended up having to squeeze those in a little bit, but I wanted to zoom in a smidge so you could hopefully see those, make them out. 12 is in the very dead center, the overlap of all three sets. 35 is in the one, is that number below. And I think the rest of them are pretty legible. But get that copy down. And now let's go ahead and work on this example. So I'm going to zoom out a bit here so I can actually put some labels here. So here's what we're going to be doing. We're going to be finding information based on notation. So we're going to be practicing notation here. Okay. I'd like to find A intersect B. All right. So visually, I'm going to locate it on the graph, and then I'm going to also indicate how many people are in A intersect B. So these would be people who take both public transportation and bike. All right. Maybe they do a combo of the two. Maybe they switch between them, but they do both. All right. Okay. So A intersect B. So real quick, here is the set A. Use my little highlighter. That's A. And then here's the set B. Okay, so where they overlap, right here in the center, that area right there is A intersect B. So those two intersect and include 12 people and 8 people. So 12 people who do all three transportation, 8 people who just do public transportation or bike. Okay, so 20 people are in that intersection, 20 people. Okay, now let's find A union B. So union implies that we are taking the elements in both sets and combining them together. So again, visually, A union B then is all of A and all of B. So all of the elements, all the people that are in those two sets, we're going to combine them together. So I'm going to go ahead and list that out. So that's going to be 35, 10, 12, and 8. All of those are just in A. 35, 10, 12, and 8. And from B, we also have 20 and another 35. All right. Grab your calculator and go ahead and add those up. So when I added them up, I ended up with 120. All right, part C. Let's find a complement. A complement. So these are all the things that aren't in A. Okay, so here's A. I'm basically going to look at everything that isn't here. So getting rid of that, all the things that aren't here. So that would be 157, 35, 20, 15. Those are all in a complement. So 157, 35, 20, 15. All right, so let me add those up this time. I got 227 for adding those up. All right, now just to pause here for a second. They do a series of like graphs where they like shade regions and kind of ask you what region that is. So I want to just take a second and come back and shade the things that I've just discussed. So for part A, when I looked at A intersect B, that would be this region right here. That region depicts A intersect B. Okay. Now I'm going to have to backtrack there. Okay. A union B. All right. So that would be all of A and B. So that's how I would depict A union B. I'd be shading in. Of course, hopefully it did a better job than my crappy little highlighter here, but that's okay. You get the idea. That's A union B. Okay. A complement, well, that is going to look like everything that isn't in A. So actually, that one's way different. Like basically, I'm shading everything but A. That's how that would look. Now, this is hard, of course, for you to depict on your paper, which is why I'm just kind of discussing it with you right now. And I'm deleting it because, like I said, it's very difficult for you to depict. But if you need to come back and look at this again to kind of use when you get to the problems that have these shadings, maybe that'll help. So this would be what the complement of A looks like, everything that isn't in A. All right, there we go. Kind of did that. I might pause later and do that again as we do some more shading. But I mean, more examples here, but we're going to kind of zoom out a little more here. Part D. Okay. So now I want to find A prime intersect B, or A complement intersect B. All right. So I'm trying to figure out what's in A complement and in B. Okay, now I just deleted what A complement was, right? That was basically everything not in A. Here, I'll do my really crappy shading here. Let me make it big so that it doesn't take so long. Okay, everything not in A. Everything out here. Okay, terribly done, but that's all right. I didn't need to do a really good job right now. So everything that's not in A, so basically all of these numbers, right? All of these numbers, but is in B. That's what the intersection means. So these two are in B. So that would be 35 and 20. So those are numbers that are in B, but not in A. So that's 55 people that are in that bike only and do not take public transportation. Visually, if I were to shade that, that would just shade this section only, just this. Everything in B, but not in A. That's how that would look. Okay, moving on. Part E. All right. A intersect B intersect C. So all three of them intersected. Okay, well, that's kind of nice. That's basically where all three of them overlap, what all three sets have in common. And thankfully, that's super easy to see. It's the little center of this. It's 12. Nice. Okay, so part F is A intersect B intersect C complement. So we want everything that isn't what they have in common. Okay, that one intersection. So basically everything outside of 12, everything outside of 12. So here, I kind of, unfortunately, I have to keep zooming out to make this work. I'm sorry. Okay, so let's see. That is 157, 35, 20, 10, 8, 35, and 15. Okay, so I'm just going to circle them. 157, 35, 20, 10, 8, 35, 15. Basically everything but 12. All right, let's add those all up on the calculator. And I'm literally going to do this because I didn't prepare ahead of time. 8, 35, 15. All right, I'm getting 280. All right, lovely. One more example. Squeeze it down here. Part G. So I want to find A union B intersect C. So A union B is what A and B have in common. And then I want to see what it has in common with C, that union. Okay. So I'm going to highlight A union B, and then I'm going to look at where what it has in common with C. Okay, so A union B, here's A, here's B, A union B. Okay, so that's A union B. And what they have in common with C are these. All of these numbers are in C as well. So that would be the intersection of those two things. Okay. Let me go ahead and get rid of the highlighter. And there we go. All right. So that would be 10, 12, and 35. All right. So 45, 47, 57. Hopefully I did that right. 57. Okay. And that would be what I showed there. Now, visually, I kind of drew it badly because I was trying to show A union B to help us do it. But if I just wanted to shade this result, okay, this 57, that means I'd be shading. Here, let me make my highlighter a little bit smaller. Okay, cool. So I would be shading this, this, and this. This is what A union B has in common with C. That's how I would shade just that part G. And there you go. So you'll be doing some examples that kind of look at this notation and try to make sure that you understand what the notation means based on the picture, the Venn diagram.